Uh, Before starting my presentation, I would bow down to my Guru, Pramukh Swami Maharaj, who is the creator of Akshardham temple in New Delhi. Now he is constructing a new Akshardham temple at America, Robinsonville, New Jersey. So I bow down to him and a prayer for him. Srimat Sadguna Shalinam Chidachidi Vyaptam Chadevyakrutiam Jive Sakshara Mukta Koti Sukhadam Naikavataradhipam Gneyam Shri Purushottamam Munivare Vedadikirtyam Vibhum Tanmulakshar Yuktameva Sahaja Nandam Chavande Sada. Next slide, please. So my talk is on Aryabhata and his contributions. So this is the statue of Aryabhata at Pune. Next. Yeah, Aryabhata. So Aryabhata was the first in the line of great mathematicians and astronomers from the classical age of Indian mathematics and Indian astronomy. His most famous works are the Aryabhatiya, just when he was 23 years old, and the Arya Siddhanta. So he was just 23 years old when he wrote this Aryabhatiyam. So we can understand that how genius he was. Now I can very well relate this because I am of the same age. So I can understand, not only understand, but also realize that how great he was. The mathematical part of the Aryabhatiya covers arithmetic, algebra, plane trigonometry and spherical trigonometry. It also contains continued fractions, quadratic equations, sum of power series and a table of signs. The Arya Siddhanta is a lost work on astronomical computations. It is known through the writings of Aryabhata's contemporary Varamira and later mathematicians and commentators including Brahmagupta and Bhaskaravan. Next. Aryabhata provides no information about his place of birth. Since we know that Indian mathematicians, Indian rishis have a certain type of speciality in them. They don't reveal their identity that much, or they don't want fame. They are not egoistic. So the same thing goes for Aryabhata too. The only information comes from Bhaskaravan, who describes Aryabhatiya as Asmakiya, the one who belongs to the Asmaka country. It is widely attested that during the Buddha's time, a branch of the Asmaka people settled in the region between the Narmada and the Godavari rivers in central India, today the South Gujarat and the North Maharashtra region. Aryabhata is believed to have been born here. And also the contemporary the Bhaskaracharya, who has written the Bhashya of Aryabhatiya, also was of the Gujarat region. He was born in Saurashtra region at the Tulsi Shyam village. Next. So Aryabhata worked on the approximation for pi and may have come to the conclusion that pi is an irrational actually. In the second part of the Aryabhatiyam, Ganitapada 10, he writes, Chaturadhikam samashta gunam dvasashtis tatha sahasranam ayutadvaya vishkambhasyasanno vritta parinaha. So here Chaturadhikam means add 4 to 100, samashta gunam means multiply by 8, dvasashtis tatha sahasranam, and then add 62,000 to that number. Ayutadvaya. Ayut means 10,000. Ayutadvaya means 20,000. So Ayutadvaya, Vishkambhasyasano. Vishkamba means the diameter. Vishkamba means the diameter. And Asana, Vritta Parinaha. Vritta means the circle. Parinaha means the circumference of the circle. So he says, add 4 to 100, multiply by 8 and then add 62,000. By this rule, the circumference of a circle with a diameter of 20,000 can be approached. Further computing, we get 62832 upon 20,000, which gives 3.1416, which is accurate to 5 significant figures. Next. It is speculated that Aryabhata used the word asana, approaching, to mean that not only this is an approximation, but that the value is incommensurable or irrational. Means that the value is not exactly 3, but it is 3.1416, And recently, people have computed the digits of pi to many significant digits. If this is correct, it is quite a sophisticated insight, because the irrationality of pi was proved in Europe only in 1761 by Lambert. So this Aryabhata had written his Aryabhatiya in 499 CE. So it is way before Lambert gave the exact meaning of the word asana. So this was quite, this is quite interesting. Next. His computational paradigm was so accurate that the 18th century scientist Gulilam Le Gentil, during a visit to Pondicherry, India, found the Indian computations of the duration of the lunar eclipse of 30 August 1765 to be short by 41 seconds, whereas his charts by Tobias Mayer were long by 68 seconds. So we can see that the charts prepared by Tobias Mayer was accurate, but Aryabhata was far more accurate than Tobias Mayer in his computational paradigm. Next. Aryabhata also, see the Aryabhatiya which Aryabhata has composed, it is basically a treatise on astronomy, but it also includes some parts of mathematics. So he gives the area of the triangle. The formula for the area is present in half Arya, that is Tribhujasya Falashariram Samadalakoti Bhujarda Samvargaha. Tribhuja, as we know, Tribhuja. Bhuj means the side. The structure which has three sides, that is a triangle. So Tribhuj is the triangle. Tribhujasya Falashariram. Falashariram means the area. Samadalakoti Bhujarda Samvarga. The product of the perpendicular dropped from the vertex on the base and half the base gives the measure of the area of a triangle. Bhaskar in his commentary observes, the term Samadalakoti means the perpendicular dropped from the vertex on the base of a triangle, that is the altitude of the triangle. It should not be interpreted as the upright which bisects the triangle into two equal parts. If we do so, the applicability of the above rule will be restricted to only equilateral, that is Samatrayashra, and isosceles triangle, that is Dvisamatrayashra. Next. This is the classification of triangles, and this is the Bhaskara's commentary. Bhaskaracharya, while commenting on the verse presenting the formula for area of a triangle, provides some edifying notes starting with the classification of triangles. Bhujaha, Bahu, Parshvamiti, Paryayaha. Paryaya, we know, these are the synonyms. So Bhuja, Bahu and Parshva. These are the three synonyms which can be alternatively used. Tatra Trini Kshetrani Sama Visama Vishamani. So a Samatrayashra, so it has 60-degree angle on each side. So that is an equilateral triangle. So that is a Samatrayashra. Sama means equal, Trayashra means triangle. Then the second one is Dvisamatrayashra. It is the isosceles triangle where two sides are of the equal angle. Then the third one is Vishamatrayashra, means it is the scalene triangle where no angle is equal to one another. Next. Area of a triangle, the formula encoded in the Arya is Tribhujasya Falashariram Samadalakoti Bhujarda Samvargaha. May be expressed as Tribhuja Phala is equal to Bhujarda into Samadalakoti. See, the Samvarga means multiplication. So Bhujarda into Samadalakoti. Bhujarda means half of the base and Samadalakoti means height, or we can take the altitude of the triangle. So the area of the triangle comes as half into b into h. So this is the formula we use, we study in the schools also right now. Next. Area of a triangle. So this is also an interesting question, dilemma, in the sense that if we know the altitude, then we can find the area of a triangle. But if we don't know the altitude, so this is the formula used. The formula half into base into height as given by Aryabhata can be employed only when the altitude is known. If altitude is not known and only three sides are known, then how do we find the area? So Bhaskar in his commentary presents a method by which we find the segments of the base BD and CD called abadhas, abadha, and hence the altitude P. So as shown in the triangle, A, B, C and AD is the perpendicular. So BD and CD, they are called the abadha. So abadha, the two abadha, when they were joined together, it forms the base of the triangle. The difference in the abadhas is given by A diff is equal to BD minus CD is equal to C square minus B square upon A. Here BC are the karna. See, you can see here the line AC has been named B and AB has been named C. So these are the two hypotenuses of the respective triangles, and Aryabhata has called the hypotenuse as karna. So B, C are karna and bhuja means the side of the triangle. So abadhas is equal to half bhumi plus or minus A difference. So altitude we can get is equal to under root of karna square minus abadha. Karna means, as I told you, the hypotenuse of the side of the triangle. Next. So this is a numerical example where Bhaskaracharya quotes the relevant formula. Numerical example in Bhaskara's commentary. Karna strayodasha syat panchadashanyo mahi dvisaptaiva vishama tribhujasya sakhe falasankhya ka bhavedasya. So this is a vishama tribhujasya. So in a scalene triangle, one of the hypotenuse is 13 and the other is 15. The base is 2 times 7 only. I mean it's 14. Oh my friend, please tell me what would be the measure of the area of this triangle. Having posed this problem, Bhaskara presents the solution in prose as follows. So he asks the questions also, he gives the answer also. So answer is Panchadashakena Karnena Navapramanena Cha Abadhantarena Labdha Samadala Koti Dwadasha. So he gives the, I will tell you, Panchadashakena. Panchadasha means 15. So here you can see now Samadala Koti is equal to under root of 15 square. So Panchadashakena Karnena Nava Pramanena. Here also Nava means 9. So subtracting it by 9 square. Pramana means subtracting. Cha abhadhantarena labdha samadala koti dwadasha. So we get under root of 15 square minus 9 square is equal to 12. Apicha trayodasha pramanena karnena pancha pramanena cha abhadhantarena labdha saiva samadala koti dwadasha. In the similar sense, we get under root of 13 square minus 5 square is equal to 12. Phalam samadala koti bhujardha samvargah bhuja bhumihi tasya ardha sapta samadala koti bhujardha samvargah iti phalamagatam 84. So we get the formula, we get the area of a triangle by this example. Bhaskaracharya has given an interesting example. Next. Now the area of a circle. How to compute the area of a circle? The formula given in the following arya is Samaparinahasyardham Vishkambhardha Hatameva Vrittaphalam. Maybe it may be expressed as Phala is equal to Parinahardha. I told you earlier that Parinaha means circumference. So Parinahardha means half of the circumference. Then Vishkambhardha. Vishkamba means diameter and Vishkambhardha means half of the diameter. It can be also called as radius. So area is equal to half circumference into semi-diameter is equal to pi r square. We get the direct formula from this shloka. Commenting on the usage of the word eva, Bhaskara observes. Now the above formula, Samaparinahasyardham, that is written by Aryabhata in his Aryabhatiya, and this is the bhashya written by Bhaskaracharya. He says, eva kara karanam arya purunartham pratipattavyam athva eva kara karanena upaya niyamaha kriyate samaparinahasyardham vishkambhardha hatameva vrittaphalam nanya dupayantaramiti naitadasti upayantara shravanat anyatra vyasardha krutis tringna ganitam iti naitadupayanantaram sukshmam kintu vyavaharikam iti. So all this is translated. or to be more appropriate, the use of the word eva is to indicate that this is the only means to obtain the area of a circle. There is no other means. See, na anyad upayanantaram iti. There is no other means. This is not true since it is 3 into r square. So we know that the area of a circle is pi r square. So pi cannot be taken as 3, but it can be taken as, because last he has written vyavharikamiti. So in vyavhar, in real life problems, we can approximately use 3 as pi, but it is not true since pi is equal to 3.14. This alternative method is not for obtaining the accurate value, but vyavharika means it can be used in daily life purposes, just for appropriate use. Next. Now, dealing with the arithmetic progressions. See, Aryabhata was an expert in astronomy, was an expert in mathematics also, but he also knew the algebraic methods also. So he gives some of the formulas which today also we recollect and we study in the school level or elementary mathematics. Dealing with the arithmetic progressions, ishtam vekam dalitam sapurvam uttaragunam samukham madhyam ishtagunitam ishtadhanam tu athava adyantam padarthahatam. So the given number of terms is diminished by 1 and divided by 2. See, ishtam means whichever term you want to take in a sequence and series for a AP, GP, HP, arithmetic progression, geometric progression, harmonic progression, whichever number you want to take in the first term, that is your ishtam, means whatever you feel like. Next, vyekam means it is diminished by 1, means minus 1, subtracting by 1, that is vyekam. Then dalitam means divided by 2. Dalitam means divided by 2. So this is increased by the number of the preceding terms, if any, and then multiplied by the common difference. See, uttaragunam means it is multiplied by the common difference and then increased by the first term of the whole series. The result is the arithmetic mean. So this is madhyam. Madhyam means how to find the arithmetic mean of a sequence and series of the given number of terms. This multiplied by the given number of terms is the sum of the given term. Alternatively, by multiplying the sum of the first and last terms or the series or partial series, which is to be summed up by half the number of terms. We all know that if we want if we know the first term and the last term of any series, then if we want to find the arithmetic mean, then what we have to do? A is equal to half of A plus L. That is the same thing he has given here. Next. अत्र बहुनि सूत्राणि मुक्तक व्यवस्थितानि तेषां यथा योगम संबंधः. So it has been pointed out by Bhaskara that many formulae, bahuni sutrani, many formulae have been set out in this verse separately, or that is muktaka, that is called, and that the need to be culled out by an appropriate combination of the words. Tatra yatha yogam sambandha means that has to be appropriately joined together or appropriately combined together to find a perfect answer. Next. The formula to compute the mean value, madhyam dhana and sum of n terms, that is called gachha dhana. So the same formula here, ishtam vekam dalitam sapurvam uttaragunam samukham madhyam ishtagunitam ishtadhanam tu athava adyantam padarthahatam. So the formula 1 is ishtam vekam dalitam uttaragunam samukham iti madhyama dhana nayanartham sutram. The desired number of terms decreased by 1. Vekam means decreased by 1. Then dalitam means halved. Uttaragunam means multiplied by the common difference. And increased by and samukham means samukham. So the first element of the whole series is called the mukh. So samukham. So and increased by the first term is the formula for computing the mean value, the arithmetic mean. Next. And this is the formula 2. Madhyam ishtagunitam ishtadhanam iti gachha dhananayanartham. The mean value multiplied by the desired number is the formula for computing the sum of n terms. So consider an arithmetic series of the form a plus d plus a plus 2d, and the series goes on endlessly. The two formulae may be given, may be expressed as mean is equal to 2a plus n minus 1 into d, and the sum is equal to 2a plus n minus 1 into d, the whole multiplied by n. So if we want to get the sum of the whole series, we have to multiply the n number of terms with the mean, so we'll get the sum. Next, I thank all of you to have listened to my speech, and I also thank Ashadhara and the whole family, Dharma Jagriti Trust, to have helped me to give an opportunity to speak here. Thank you.